Bismillahirrahmanirrahim. Assalamu alaikum students. Hope that you all are doing well. This is week 4 and day 4 of class 9 physics, and today I am here to discuss the first topic of unit number 6 with you. And the name of the topic is work. What does work means to you? Are you doing work when completing your homework assignment or writing an essay? You will say, "Oh, today we have done a lot of work." But in physics, actually you haven't. In physics, the work has a precise meaning. They said a work is done only when a force is applied on a body and the body covers the displacement in the direction of the force. Let's say this, we have an example of a block here. I am applying a force on this body. The body is covering the displacement in the direction of the force. So it means that it is doing a work. What is considered as work done in physics? If you are pushing a heavy shopping trolley for 10 meters, it means that you are doing work. If you're pushing a trolley, it means you are applying a force in the forward direction, and the body will also cover the displacement of 10 meter in the direction of the force, which is in the forward direction. So you will say that you have done some work. Now, what is not considered as work done? The example here we have is if you are pushing against a wall. If you are pushing against a wall, it means that you are applying a force on the wall, but the wall is not covering any displacement. When the body or the wall is not covering any displacement in the direction of the force, then the work done will be equals to 0. Or we can say that I am holding a bunch of books on my head and I am not moving. In this, I am applying the force, but the thing is that I am not covering any displacement. So the work done will be 0. Let's see an example here. This is a block. I am applying the force in the forward direction, and the body is covering the displacement in the direction of the force, and it is also covering it in the forward direction. So the work depends upon two factors. First one is the force and second one is the displacement. So the formula of work is equals to the product of force and displacement. W is equals to F cross S, where W is the work, F is the force and S is the displacement in the direction of the force. Now what will be the units of force? As we know that the unit of force is Newton, the unit of displacement is meter, so the unit of work will be Newton meter. In SI unit, we have an international name of this unit and we call it as joule. So 1 joule is equals to 1 Newton meter. Sometimes force and displacement do not have the same direction, as you can see in this figure. A boy is pulling a cart by applying a force in this direction, and the trolley is moving in this direction. So the force is acting in this direction and the trolley is covering the displacement in this direction. Here you can see that force is making an angle theta with the surface on which the body is moved. So what will I do? I'll resolve the force into its perpendicular components, which is Fx and Fy. Now we know that Fx is equals to F cos theta and Fy is equals to F sin theta. Here force and displacement do not have the same direction. Only the x component is in the direction of the displacement. So it means Fx causes the body to move in that direction. And because Fy is perpendicular to the direction of the displacement, so Here Fy is not providing the body, causing the body to move. So W is equals to Fs and F will be represented as Fx, whereas Fx is equals to F cos theta. Now the formula in which the force and displacement do not have the same direction, we can calculate the work done from this formula, which is W is equals to Fs cos theta, where F is the force, S is the displacement measured in meter, and theta is the angle with the surface on which the body is moved. Now what is the unit of work? It's joule, as joule is equals to Newton meter. When a force of 1 Newton moves a body through a distance of 1 meter in the direction of the force, then the work done is equals to 1 joule. Now we will discuss some cases of work, that when the work will be zero, when we will have the maximum work, or when the work will be negative. Let's say the first example. I was having a body and I am pushing it in this direction. The body is covering the displacement in the same direction. So here the theta will be equals to 0, as W is equals to Fs cos theta, as theta is equals to 0. So cos of 0 is equals to 1. You can calculate it from the calculator. Cos 0 is equals to 1. So we will get the answer as Fs or Fd. Here the work done will be maximum, or we can say it is also known as positive work. Let's discuss another case related to work. This is a bucket. I am holding a bucket and applying the force in this direction, and I am moving it in this direction. Here you can see force and the displacement are making an angle of 90 degree, or we can say they are perpendicular to each other. Or we can take another example of a boy that is having a load on it, and it is applying a force in this direction, in the upward direction, and it is moving in the forward direction. So the angle between the force and the displacement is 90 degree. So when the force is perpendicular to the displacement, it means the theta is equals to 90 degree, or the theta or the angle between the force and displacement is 90 degree. So as we know, W is equals to Fs cos theta. So here we will replace theta as 90 degree and cos of 90 is equals to 0. So there will be no work done, or we can say in this case the work done will be 0. Third case we have here is of negative work done. In this, the force and displacement are making an angle of 180 degree. Let's say the weight of the body is acting in the downward direction and the body is covering the displacement in the upward direction. Here you can see the displacement and the force are making an angle of 180 degree. So what would happen? When the force and displacement are in opposite direction, or we can say they are making an angle of 180 degree, so as we know that W is equals to Fs cos theta, we will replace theta as 180 degree and cos of 180 degree is equals to -1. So the work done will be negative. So we have three cases. First one, the case where the work done will be 0. Second one, the case where the work done will be maximum. And third one is the case where the work done will be negative. If we were talking about the 0 work done, here we said that force is perpendicular to the displacement, so the work done will be 0. We also have another example. Let's say that I am applying a force on the body and body is not covering any displacement. So here the S will be equals to 0. So F multiplied by 0 will also be equals to 0. Or in this, the displacement is equals to 0. Body is not covering any displacement. Or we can take a third example here. Let's say the force is equals to 0. I mean that I am not applying a force on a body, but the body is covering the displacement. So here, if I'm not applying any force on the body, then F will be equal to 0, and 0 multiplied by S will automatically, the work done will be equals to 0. So if we are talking about the case of zero work, then we should know if the angle between the force and displacement is equals to 90 degree, then the work done is equals to 0. If the force is equals to 0, then also work done will be equals to 0. And if the body is not covering any displacement, then again the work done will also not be equals to any value. Let's see an example here on page number 121 of your textbook. The example is a girl carries a 10 kg bag upstairs to a height of 18 steps, each 20 centimeters high. Calculate the amount of work she has done to carry the bag. They said the mass of the bag is 10 kg, and as we know, weight is equals to mg. So m is the 10 kg, and we know the value of g is 10 meter per second square. So the weight will be equals to 100 Newton. Now you will have a confusion that we are also representing a weight by W, and we are also representing work by also W. So for this, work is represented by capital W while weight is represented by small w. Now for displacement, each stair is 20 centimeter high. And as we know that the stair has 18 steps, so height will be equal, or displacement will be equals to 18 multiplied by 0.2 meter. We have converted 20 centimeters into meters, which is equals to 0.2. So the height will be 3.6 meter. So as we know, W, that is work done, is equals to Fs, force is equals to 100 Newton, and displacement is equals to 3.6 meter. So the answer we will get is 360 Newton meter, or 360 joule, where joule is the unit of work done. So your task is to memorize the cases, formula, unit, and definition and example of work done, and write it on your notebooks.